welcome everyone and welcome back to my channel. As you know, we have started Maths and Physics GCSE series, and in Physics we have already done the basics, which is about the displacement, scalar vector quantities, and these VT and SC time graphs that we have already covered in our last class, in our last lecture. And today we are doing questions on it. So this is how it works. I keep on posting the theory, then related questions, then theory, then related questions, and once we'll complete the whole topic, we'll be doing some more harder question, experimental questions. That means the questions related to the experiments and the past paper questions. In this way, we will be summarizing our whole topic. So this sheet is all about the questions on VT and ST time graphs that we have already completed previously. So question number 1 says, if a car is traveling in a straight line during the time interval of 400 seconds, here is the velocity time graph for the motion, and this one you can clearly see, and it says that calculate the acceleration of the car in the interval of 0 to 200 seconds. See, from 0 to 200 seconds, that means from 0 to 200. And we have to calculate the acceleration for this one. So acceleration is what? In a velocity time graph, the gradient will give you the acceleration. So that means we have to calculate the gradient of this graph. And gradient has the same formula, which is change in y over change in x, which is y2 minus y1 over x2 minus x1. Keep that in mind that the gradient of a straight line always remains same. That means whenever you see a straight line, it represents a constant gradient. Because on a VT time graph, that is velocity time graph, gradient is acceleration. So if it's a straight line, I can easily understand that this is basically a constant acceleration graph. And if you are confused, you're not aware of these things, I have already covered the video, the theory video on it. I'll attach the link in description box. You can just click and you can see those that video. Now, gradient is y2 minus y1 over x2 minus x1. Why I was telling you that the gradient is same on a straight line, that means you can pick any 2 points and you'll get the same answer. Here, these two coordinates are known, which is 0, 300, and this one is 200, 0. So y2 minus y1, you can name any coordinate as x1, y1 and x2, y2. So let me take this one as x1, y1 and this two as x2, y2. So y2 minus y1, that is 300 minus 0 over x2 minus x1, that means 0 minus 200, and which is equals to negative 1.5 meters per second squared, as they are asking you to calculate acceleration. This negative represents that this is deceleration. That means the particular vehicle is constantly decreasing its velocity, and that's why it's a retardation or deceleration. II says, find the ratio of the distance traveled by the car in first 200 hours from 300 to 400 seconds. That means you have to calculate the ratio of the distance traveled by the car in first 200 hours and between 300 to 400 seconds. These two distances we have to calculate and divide them together to get the answer. So that means ratio should be distance in starting of first 200 seconds. It's not hours, it's a misprint, so it has to be seconds, over 300 to 400 seconds. That means distance traveled between 300 to 400 seconds. So we have to see distance traveled from starting 200, this much. In a velocity time graph, the distance is given by the area under the curve. From 0 to 200, it's a triangle, and we have to calculate the area of this triangle, which is half times base, which is 200 in this case, times height, which is 30 in this case. So that will give you us 100 times 30, which is 3000 meters. So 3000 meters is what? The distance covered in starting 200 seconds over 300 to 400 seconds. 300 to 400 seconds, that means between this one. So we have to calculate this height, which is 20, and this one is 100. So half times base is 100 times height is 20. So this is 1000. So between this is 1000 meters. So ratio is 3. Third one says calculate total displacement over its entire journey. There's a basic difference between the distance and the displacement, because distance is a scalar quantity whereas displacement is a vector quantity. That means if we have to calculate distance, I have to calculate area of each and add them up. Only the positive values, right? But for displacement, still we have to calculate the area, but if it's below the x-axis, we have to take the negative answer, whereas if it's above x-axis, we have to take the positive answer. That means the question says we have to calculate the total displacement of the journey. That means we have to calculate the area under curve. This one we have already calculated as 3000. This one we have calculated as 1000. And for this one, height is 10. This one, right? Height is 10 and the base is 100. So this will be half times base and height, which will give me 500. So this is 500. If they have asked me for the distance, I would have added 3000 plus 500 plus 1000, that is 4500 would be my total distance covered throughout the journey. But they're asking us to calculate displacement. So in that case, instead of adding plus 500, because this is below the x-axis, I'll take it as a negative. So my total displacement will be 3000 above the x-axis minus 500 because it's below the x-axis plus 1000, which is 3500 meters. So that's the displacement. Now the fourth one says calculate the total distance covered by the car in this journey. So same 3000 plus 500 plus 1000, which is 4500 meters. That would be the total distance covered by this car in this journey. Moving on to the question number 2. Given figure is the velocity time graph for the motion of a truck. Estimate the total distance covered by the truck in this journey. So that means we have to calculate the area. Why they are asking us to estimate it? Because it's not a very known figure, it's a curvy one, and it's not easy or to divide it into the known figures for which we can calculate the area. So because this is an estimation, that means we have to divide this figure into known figures, because I can't calculate the area of this one because it's a curved one. So for that, either we can divide it into a trapezium or triangle. So let me try to break this like this. First we have to see this is 40, like with the known we can say. Okay, so this one's 40. Till here it's going 40. Then here till 30, let me draw a straight line like this. This is 20 and this is 10. So if I'll join like this, no, we can't. So try to convert this into triangle directly like this. If I'll convert this into triangle, I mean this one, either directly take the whole trapezium or convert it into triangles and rectangles and draw a straight line like this. It will go approximately at 40, and then this one. So I can divide it into 3 figures or directly apply the formula of a trapezium. So we are calculating the area of this whole trapezium, this one. And we know the area of a trapezium is what? Half times sum of parallel sides. So sum of parallel sides is what? This one is 20 clearly, plus this one. There are two bases, this one and this one. The smaller one is 20, the greater one is 80. So plus 80 and times height, which is 40. So this will give us an approximate estimation of this one, which is half times 100 times 40, and that will give me 2000. Because we have already excluded this one and this one, that means clearly we have calculated little lesser than the actual value, and that's what they are asking in the second part. It says, is this an estimate, an overestimate or underestimate? What you have estimated, definitely your answer is 2000, but because we have excluded these values, that means maybe the answer would be 2500, 600, but the actual answer is greater than what you are or what you have calculated. That means you have done underestimation. This is most common confusion. I'm a teacher. I have an experience of 7 years, and I know many students, they feel like stuck when they just have to answer is underestimate or overestimate. They get confused. You have to tell underestimate and overestimation according to your answer. If your answer is lesser than the actual answer, which we can clearly see, that means you have calculated lesser. So what you have done, you have underestimated. If suppose somebody asks you, okay, you just tell me that whether this person has a capability to win this prize or not, and you said no, I don't think so, and at the final he just won. So then you will be saying, oh, I underestimated your capability. So that means you have rated him lesser than what his actual potential is. Similarly, you have calculated the lesser value than the actual, and that's why it's an underestimate. Moving on to the question number 3. Given figure is a velocity time graph for the motion of a body, and this is a VT time graph. The total distance covered by this body is 1800 meters. Then calculate the value of x. So here it's x. This is a trapezium. We just have to calculate the area of this trapezium, and that's equals to 1800. Because in VT time graph, the area under curve will give you the distance. So I'm applying the formula for area of a trapezium. Half times sum of parallel sides. So this one is from 100 to approximately, let's say this is actually approximately 300 something. This is, if I'll draw this. So this one is 300 minus 100 is 200, plus this one is 400 times height, which is x, and this is equals to 1800. So this one will give me 300, x is equals to 1800, and x is equals to 6. So this is 6 basically. Now the graph shows the body finishes where it started. Stay true or false with the reason. So graph is showing that from where it started it ended. So in that case, from if in VT time graph, if I'm calculating, if it's starting from where it is, the total displacement should be 0 in this case. In short, I've just explained you the area under graph will give you the distance and displacement. So if it's above the x-axis, it's positive. If it's below the x-axis, it's negative. So if I'll calculate the displacement here, that's also 1800 in this case. So if displacement is 0, then we can say from where it started it ended. But if the displacement is something greater than 0, that means it's clearly not, if it's a non-zero value, that means clearly it states that displacement is what? It's ultimately, it's not from where it started, because displacement is, if suppose I've started and done this whole journey and come back to the same position, B. So what's the shortest distance between A and B? It's just a point. That means displacement is 0. So if it says that you have to prove that the body starts and finished at the same point, in that case displacement should be 0, which is not in this case. Now for the last one, after 300 seconds, body slowing down at the rate of y meter per second squared, calculate y. So after 300 seconds, which is here, it starts to deaccelerate. So this point we have just calculated is 300,6, and this one is 400,0, and acceleration is gradient. So y2 minus y1, so 0 minus 6 over x2 minus x1, which is negative 6 over 100, or negative 0.06 meter per second squared. So negative represents that it's deaccelerating, and that's your answer. Now question 4 says, given is the displacement time graph of a body, what kind of motion is shown by this body from 0 to 20 seconds? From 0 to 20 seconds, here we can see it's clearly a straight line. That means it's a constant velocity because gradient is constant in this. Now for II, it says what kind of motion is shown by this body from 20 to 50 seconds. From here 20 to 50, it's not a straight line, it's showing me a curve. That means this is showing me a curvy feature, which is a non-constant velocity, that's called acceleration. So this graph is showing me that it's actually accelerating. Now calculate the velocity at 40 seconds. At 40 seconds, that means here this is 40, and if we have a curve, if it's a straight line, it's easy to calculate the gradient, but if it's a curve, the only way is to draw the tangent at that point. So they're asking at 40, that means I have to draw a tangent at 40 like this, and I have to calculate the gradient of this straight line. So basically we have to pick 2 points, approximately we have to pick the 2 points. So let's say one point be 30 and it's 100, it's here. So one point is 30, 100, and second point B, let's say at 80, this point is approximately 50 or something. Let me just see. If I'll draw a straight line like this, where it's touching this, and if I'll draw a straight line downwards, it's approximately will give me 50. So approximately it has to be like 50. So we can say our point B 50, 80. So 50, 80. Now we can calculate the gradient, which is change in y over change in x. That means 100 minus 80 over 30 minus 50. That will give me minus 1. So minus 1 is the velocity at 40 seconds. So minus 1 meters per second. Question 5, explain what the gradient of a velocity time graph represents. So I have explained to you in the last lecture as well, in this as well, that it's acceleration. It's very easy to find the gradient. Gradient is change in y over change in x. On VT time graph, velocity is on y-axis and time is on x-axis, and change in velocity over time, v over time, is acceleration. So that's the reason that the gradient is acceleration. Part B, velocity time graph is horizontal line. What does this tell you about the motion of the object? See, this is VT time graph. This is V, this is T. Let's say this is horizontal line, this one. What does this tell you about the motion of the object? If it's parallel to x-axis, that means clearly the tangent is what? That's 0. If I mean the gradient. So gradient of this straight line is 0, and if gradient is 0, that means it's not accelerating, it's moving with constant velocity. And just by looking at the graph, you can clearly see that velocity is constant throughout. Suppose this is 10 and this is 1, 2, 3. So here velocity is 10, after 1 second, after 2 seconds also same, after 3 seconds also same. That means clearly it's telling me it's constant velocity. Part C, on a velocity time graph, the line slopes downwards towards the time axis. What does this indicate about the object's motion? So this is your VT time graph and it's going downwards. That means gradient is obviously negative here in this case. And if it's like this, that means it's increasing. So gradient is positive. Here the gradient is negative. That means it's deaccelerating. Gradient is negative. Gradient of VT time graph is acceleration. If it's negative, that means your acceleration is negative, so it's deaccelerating. Part D, what does the gradient of a displacement time graph represents? Displacement time graph will be doing the same. Displacement time gradient is change in y over change in x. On y-axis it's displacement, on x-axis it's time, and displacement over time is velocity. That means the gradient of displacement time graph is velocity. Part E, the gradient of a displacement time graph is 0. What does this indicate about the motion of the object? Now the gradient is 0, that means your velocity is 0. Something it's stationary. See, if this is displacement time graph, and if the gradient is 0, that means it's like this, horizontal one. And if it's horizontal one, that means you can clearly see time is passing but displacement is 0. So that means object is stationary. Question number 6. Define a scalar and a vector quantity and give 3 examples. So scalar quantities are those quantities that have only magnitude. That means examples are mass, time, distance. Obviously we cannot define their direction. Mass, how can I define the direction of it? Or time is always, we consider it to be linear. And distance, so I can never say my distance was 10 meters towards left, right. It's if you are taking a curvy path, how can you define the direction for this one? So that's why these are the 3 examples. There are so many examples, but as they're asking 3, so these are 3 examples for scalar quantities. Vector quantities are those quantities that have magnitude and direction both. Apart from the magnitude, that means the value. Apart from the value, you are able to define their direction as well. That means displacement. Displacement is the shortest distance between 2 points. That means a straight line. And if you are moving in a straight line, it's very easy to define the direction. Velocity, acceleration, force, these all are the examples of vector quantities. Part B, state whether the following are scalar or the vector quantities. Speed. Speed is a scalar quantity. Velocity is a vector quantity, because a scalar is distance over time, how much distance you are covering over a period of time. So this is a scalar quantity. Displacement is vector, energy is a scalar, and force is a vector quantity. And the very last one, why is velocity considered a vector but the speed is considered a scalar? So velocity is vector because it easily tells you the magnitude and the direction, whereas the speed tells you only about the magnitude. And also the velocity is displacement over time. So displacement over time, that means we know that displacement is shortest distance, and that is a vector quantity. The displacement is telling you in which direction something is heading with respect to time. That means obviously you know its direction, whereas a speed is distance over time, and distance is something I told you that if you're taking too many turns and like left and right turn, you won't be able to define a single direction. And speed is distance over time. That means your distance is something that is not giving you any idea of direction. So obviously the speed will also not give you any idea for direction, hence it's a scalar quantity. So that's it for today. If you're looking for one-on-one live online classes, so they are starting at just £6 per hour, and you just need to book a free demo. And for that, all you need to do is just email us at exactacademy@gmail.com. And we not only provide the classes for GCSEs, we provide classes for KS1, KS2, KS3, GCSEs, A levels, for all subjects. So, and also if you are looking for these free worksheets, they are available at exactacademy.com. So that's it for today. Bye everyone. Take care.